Hello everyone and welcome to another exciting episode of Organic Chem 1. Here we are doing the recrystallization experiment. As we see the TA setting up our test tubes per the instructions in our recrystallization procedure, they have three sets of 5 test tubes. Right? Each test tube will have um, either acetanilide, acetylsalicylic acid, adipic acid, or an unknown compound. From that, each one of these sets, so there are 3 sets because we will be exploring 3 different solvents, ethanol, acetone, and hexane, and how efficiently they dissolve our 5 compounds. All right, so we're in the setup stage. All right, so we see that they have acetylsalicylic acid that they're putting in test tubes. Now they're doing adipic acid into 3 different test tubes. It says a small scoop. Isn't it great that we don't have to weigh out each one of these small scoops? Ugh, that could get troublesome. Alright, next up, after adipic acid, they're going to start adding, well, hang on, they're making notes. They're writing on the test tubes. It's always good. You always want to write on your glassware. Alright, next up we have acetanilide. Alright, making a note on the glassware. Now, aside from also not getting confused, it's good to write notes on the glassware because it's actually um, it goes against safety code to not write on glassware what's in it. All right, and then this last compound, it appears to be the unknown. Oh, that's a new one to me. Um, y'all, I'm so special. I was saying it wrong. It was unknown. Yeah. Okay. So, all right. So now what they're going to do, for one set, they're going to add ethanol to all of their different compounds, one at a time. All right. So looking here, we have ethanol. Does it dissolve if we swirl? So for salicylic acid, yes, it did dissolve it. All right. So this is considered room temperature. If we look at acetylsalicylic acid, you can kind of see some white powder in there. It's not really dissolving. Um, yeah, adipic acid, same problem. It's not really dissolving in ethanol at room temperature. Uh, acetanilide, not really. Well, hang on, is it? The unknown did not dissolve. So yeah, it looks like the only one to really dissolve was salicylic acid at room temperature. Sorry, to dissolve in ethanol. We have to be specific here. All right, they're going to be persistent here. There we go. Let's check on it. Ooh, ooh, is it dissolving? I mean, it is a little blurry, so it's hard to tell, but kind of looks to me like it's dissolving. And I think that's why they keep shaking it. So if I had to say, acetanilide dissolved in ethanol at room temperature. Interessante. Alright. And now they're setting up the hot plate. They're going to heat up water so that they can add tubes 2, 3, 4, and 5. Okay, so they're doing that because those test tubes, and that would be test tubes that contained acetanilide, adipic acid, acetylsalicylic acid, and the unknown, those did not dissolve at room temperature in ethanol. Okay, so the only one that dissolved was salicylic acid in ethanol at room temperature. All right, and now what they're going to do is they're going to allow this beaker of water to warm up, and then they're going to go ahead and test another set of compounds with acetone. So also you can see they're making kind of a chart here of our 5 compounds, what dissolved, what didn't dissolve at room temperature in ethanol, and then after that it's warmed up in the water bath, they're going to check and see what dissolved and what didn't dissolve at higher temperature. All right. They didn't have them put their unknown, they put it on a separate piece of paper. You'll see that in a minute. But the unknown did not dissolve in ethanol at room temperature. All right, next up, let's look at what will dissolve in acetone. So adding 0.5 milliliters of acetone to another set of test tubes. There's our salicylic acid. I can't read what that is, but there's adipic acid, I can see that. I think that's acetanilide. And then, oh, wait, did you add any to the unknown? All right, so adipic acid didn't dissolve in acetone at room temperature. Acetanilide did dissolve at room temperature in acetone. And they didn't add any acetone to the unknown, so they're going to add it. Does it dissolve, my friend? And it appears, oh yeah, it definitely dissolves. Okay. All right, so salicylic acid dissolves in acetone at room temperature. So now they're putting the unknown on there as well. All right, so the unknown and acetanilide, they both dissolved at room temperature in acetone. Now they're checking the high temperature ethanol to see what dissolves and what doesn't. All right, so adipic acid dissolves in ethanol at high temperature. All right. The acetanilide dissolves in high temperature in ethanol, and our unknown dissolves in ethanol at high temperature. All right, and then of course they didn't check the salicylic acid at high temperature because it had dissolved at room temperature. So, all right, adipic acid in acetone at high temperature does not dissolve, and that's because it didn't dissolve at room temperature. All right, next up, they're going to check hexane. All right, so first up, room temperature hexane. Do these things dissolve? So there's our salicylic acid, our acetylsalicylic acid. All right, now adding it to the adipic acid. Now the acetanilide. And lastly, the, hang on, they're getting some. They're going to do it. Here we go. You can do it. Oh, wait, what? That's, okay, now the acetanilide. They must run out. Oh, and then they added some acetone to the unknown. All right, salicylic acid is not dissolving in hexane. So that'll have to go into the hot water. Do it now, maybe later. All right, checking the acetylsalicylic acid. It also does not dissolve in hexane at room temperature. Checking the adipic acid. Does not dissolve in hexane at room temperature. Checking the acetanilide. It also does not dissolve at room temperature in hexane. And next up, the unknown is not dissolving in hexane at room temperature. So none of them dissolved at room temperature. So put all 5 in the hot water. 5 of them go in the hot water. All right, salicylic acid is not dissolving at high temperature in hexane, so it gets an X. Acetylsalicylic acid at high temperature is also not dissolving when it's in hexane. All right, so hexane is definitely a horrible recrystallization solvent for those two. Adipic acid does not appear to be dissolving at high temperature in hexane. Acetanilide, also not dissolving in hexane at high temperature. Man. All right, what about our unknown? At high temperature, it's also, so none of our 5 compounds dissolved either at room temperature or high temperature at hexane. So that automatically excludes hexane as a likely recrystallization solvent. Boy, the hexane just horrible. All right, there's our results. Okay, you can pause and check the notes that you made as the video progressed. All right, now we know hexane's not going to work, and when we look at our unknown, um, our unknown, you want a scenario where it doesn't dissolve at room temperature, but it does dissolve at high temperature. So, and also you want it to recrystallize after it cools back down. All right, so really you want to say, okay, throw our unknown in a room temperature solvent, it doesn't dissolve. Then you heat it up, it does dissolve. Right? And then once you let it cool back down, you see solid forming again. So that's why they chose ethanol as our recrystallization solvent, right, as we test it. So that's why now they are going to have 2 containers, a beaker and an Erlenmeyer that have ethanol in it, and they're going to warm it up so that they can dissolve the unknown. So there's about 30 milliliters of ethanol in this Erlenmeyer flask and about 5 milliliters of ethanol in this beaker that has 500 milligrams of unknown. All right. All right, and then they're also going to heat that up to dissolve it. Now, one thing to pay attention to here, the unknown um, does have some impurities in it, so not everything is going to dissolve. You'll still see some solid. But you won't see as much. Sorry, I'll throw that in there. All right, so heating it up. All right, getting as much dissolved as possible, as much of the unknown, not its impurities, but the unknown. All right, and so they're folding up filter paper so that it will fit into a filter, a glass filter, so that they can actually separate the dissolved unknown from its impurities just by doing a filtration, a gravity filtration. We call that the lotus fold. I don't really know if it has a special name, but it's kind of like origami. That was very well done. All right, so setting up an Erlenmeyer flask with a glass funnel. All right. All right. now they're going to come to the realization that this is an awful filter to use, an awful funnel to use for this type of procedure. And so you're going to see they're trying to wet the filter paper to get it to kind of stick and retain shape. So instead they actually are swapping it to a different funnel. Right. Okay, and this one's going to work a lot better. All right. So now they're going to take their hot solution that has dissolved unknown in it and some solid impurities. All right, they poured it through, and now they're going to add some hot ethanol into it to try and catch anything that was left over. All right, they're going to do this a few times. All right, just rinsing the beaker with hot ethanol. All right. All right, and then they're going to slowly, once it stops dripping, um, then they'll go ahead and take that filtrate at the bottom. That's going to have our dissolved unknown in it. All right. Well, sorry, they got to rinse it some more too. All right, just in case any got trapped in the filter paper. All right, now this filter paper has our impurities in it. All right, so this can be discarded. All right, thrown away in solid waste, in a Ziploc bag, or all right. Okay, we can see as it's slowly not dripping. All right, and they're kind of showing you the impurities. Ew, they look nasty. All right, now they're going to allow the filtrate to cool to room temperature. All right, now this is so that the recrystallization can begin. Right, now remember the unknown does recrystallize as it reaches room temperature, but to maximize the recrystallization, having all of your unknown precipitate out of solution, you want as cool a solvent as possible, right? Because we know that solubility is dependent on temperature. So the lower the temperature, the less soluble compounds tend to be. All right, so they're putting it in the ice bath, right, after the beaker reached room temperature. Okay, all right. Ooh, y'all. All right, so we're on the process of cooling down. Whoa, y'all. Hey, y'all see that? The Erlenmeyer flask moved. I think that fume hood's haunted. All right, so now they're ignoring the ghost in the fume hood, and they're setting up another lotus origami for the filter paper that they're going to put in the funnel. And so now what you're going to see when they pick up the Erlenmeyer, since it's been in the cold water, all right, 99 molecules went in the water, and all of them precipitated out because it was cold. All right, so um, you can see it's all milky looking. Mm, trust me, that ain't gonna do a body good. All right, so uh, they go ahead now. Whenever they pour uh, this solution with cloudiness in it, the solid they're going to catch is that recrystallized unknown. All right, so pouring it through, going to rinse it a little. All right, so pouring it through, and now just to make sure they catch any of the unknown that stuck to the side of the flask, they're using ethanol. Now, what would have been better to do instead of using room temperature ethanol, they really should have had an extra beaker set aside of ethanol that they put in cold water in the ice bath, so that because some of that was stuck to the Erlenmeyer could have redissolved, and they wouldn't really have as accurate of a mass reading for their final product that gets caught in the filter paper. All right, and so now they're going to allow the filter paper to dry. So they're putting in a hot plate. Well, there's a watch glass on a hot plate, and so they're putting the paper on top of that. Now, whenever something like this happens, you do have to be careful not to burn the filter paper. A lot of times, the filter paper can burn while simultaneously you begin to melt your solid. So this is one of those things that you have to watch very closely. All right. Ooh, did you see that filter? It moved. What? What? How come that TA ain't worried about the ghost in the fume hood? What? Oh, it moved. Mm, no. No. All right, and so they checked it, and so you can see how stiff it is, so it dried. All right, so now also they're going to check the melting point of their recrystallized unknown. Why would they do that? I don't know. That's very strange. I mean, it's not like that serves a purpose or anything. Anyway, we're not actually going to see the melting take place. All right, but we can use the melting point to kind of tell us, um, oh, which we lost, but we can use that melting point to tell us what our unknown most likely was. All right. Make sure that you go back and kind of get that final mass and everything, because you are going to have to calculate percent recovery. And so be ready for that. Thank you.